So hi all. In this session, we're going to understand what is load balancer, why do we require load balancer, and what are the benefits of load balancer. Along with that, we'll try to cover some other topics in AWS too, that is auto scaling. So how exactly the auto scaling is work and what are the benefit we going to get. So when we configure with auto scaling, we'll go and see all those things fine. So this will be the agenda of this session and we'll try to understand. So probably you might get confused. So the tagline is completely different from agenda. So here we have also included many other AWS services. So before we getting into the auto scaling as well as the load balancer, we'll try to have some basic knowledges of or on VPC, that is launch template. Thereafter, we'll understand why do we require load balancer and what is target group and auto scaling. So why I have chosen all these topics to be in this session before we get into our objective line. So in an organization, if you choose to deploy your web application, so definitely they will going to have the different network for their project. Fine. So this is how exactly your organization will going to deploy the things. Fine. So that is why I just choose to be have these benefits. Fine. So we'll try to understand what is VPC and why should we use or what are the advantages and how exactly it is going to work everything. Okay. So VPC is a virtual network inside your cloud. That is why they name it as virtual private cloud. Probably people might have a VPN, that is virtual private network. So the network is deployed inside your cloud. That is why it is named as virtual private cloud. Fine. In AWS, it's logically isolated network that you can use to launch and manage only the AWS resources. So it allows you to define and control virtual network or the environment prior to your applications and business needs. So you can deploy your all your resources under your pre, that is under the custom network. So what you have, okay. So think of BBC as your private network I just mentioned, right? So it's nothing but your private network since you people are be deploying inside the cloud. That is why we call it as private cloud within AWS where you can set up subnets. So why do we require subnets? So if you have one network with 65,000 hosts or you can have 65,000 IPs available for your organization means, so you might hardly use 10,000. So rest will be the waste, right? So rest IP address will be waste. So to optimize the resource utilization, that is to optimize our network to more reliable things. So they have come up with the concept of subnet. So where you can categorize the systems or we can categorize and keep the intended or the desired system under one subnetwork and you can have multiple subnets. Each subnets can have its own intended systems. Like for example, so the HR systems are kept under one subnet and the production or the stakeholders and the manager levels, team members. So we can categorize however we want and we require route table. So why should we require route table? Without route table can we able to send or receive any requested to desired system? No, we cannot. So we should have route table. So why should we have route table? So whatever the data is coming or going out, that should be, if A is requesting some data means, so the response should back to the A itself. It should not go to some other things. For that purpose, we require route tables and the network gateway. So anyhow we have our own network, and under that network we had to have subnets and route tables and so, but there we again lack back for communicating outside our network. So if you want to share your data to the public, that is outside your organization, that is your outside your private network, you should have the network gateway. Unless until you do not have a network gateway, you are not allowed to interact, or you are not allowed to communicate or share data to outside the world from your network. So similar to how you would design a physical data center. Fine. So here we have should we use VPC. We have isolation and security. Since it's our own set of defined of network, we can set our own security rules, and it's isolated from the other networks, right? So VPC ensures your resources are isolated from others in the cloud. So your network, it's nowhere connected to somebody's private network, or it could be in the cloud. So if you are using this set of defined IP, there only your resources are available. So if you move out of that IP, your details won't be found there. So since it has a feature of isolation, providing enhanced security, so you can control inbound and outbound. So inbound is nothing but whatever the request is coming to your system, and whatever the request is going out from your system is outbound. So using the security tools, so you can define whoever can access, who are not access, like that. So this is how your company's laptops or the systems are being configured, and security groups is nothing but the firewall in other word we can have, and network access control. So that is what they are trying to expose things like. They will set some set of rules, or they will set, or they will pass some IPs in the firewalls. Only for those IPs you will be having the access. The rest you cannot access the site. Even the sites can be blocked using the firewalls. So customizable network configuration. We can have our own set of IP range, create subnet and route table, everything. Right? So integration with AWS. Since you are creating your own network within the AWS environment, so you can deploy or you can launch whatever the service the AWS wants. So you can use VPC peering and transit gateway for VPC, that is cross VPC connection. That is, if one person is sitting in one region and likes to access, or your organization might have the branch in another region, they have resources. So by pairing the things, so both network can communicate, will have more security, and they can communicate without any authentication like this, since initially the both VPC will be paired off. And scalability. So VPCs can scale with workload, enabling you to add resources. So you can add your resources like as you want. So control internet access. As we initially talked, right, we should have gateway to interact with public networks or using the net. So why should we go with net? It translate the address, network address translations for secure outbound internet access from the private network. So if you are sending some request to the public, or if you are requesting some data from the public network, so your identity will be masked, and the another things will go like this. Next is compliance and governance. So VPC helps meet industry regulations by providing the secure and isolated environment for sensitive workload. So you people might have observed that most of your organization, they provide some VPN apps to get into their network, or to get into their network, right? So if you do not enter their network, you won't be able to access whatever the resources or the websites where you people work. So that is how. And also they follow some government regulations to help the industry. So you cannot use the IP ranges like as you want. So some organization might be using something like that. So we should follow all the regulations. Right? So we just understood the concepts of VPC, and we'll have our own VPC in practical parallelly. So before we getting into this, fine. So just this is my AWS console, and I'll be searching in global search bar. Just provide VPC and go to your VPC and refresh it. Okay, so we'll change the reason. It's not like you should use only this region like that. So you can use the region wherever you want. Um, So we'll be deleting the existing VPC. And we'll check around. Do we have any other things? Okay, now the default configurations exist here, and we'll try to. Okay, that looks good. Fine. Okay, so we'll create our VPC, that is our own network inside the AWS. So for that, we'll be navigating to VPC, and we hit create button. So we have two kinds here. So either you can go with fully automation, that is you don't want to configure each and every steps individually. So you can go with create VPC and more on one click. Or if you want to have your things to be configured individually, you can use this one, so manual method. So here I'll be providing the name of your network or my network. Fine. So the main objective of this session is we'll try to implement load balancer as well as auto scaling, right? So regarding, or I'll be using the relative name to my object line. Right? So here you need to provide your network, custom network. So it's not mandatory to give the network like this. You can have your network. So whenever you see this forward slash 16 forward slash 24 forward slash 28, so maximum you can have between the ranges 16 to 24, 28. If you go beyond this, you won't get much IP address, and the IP address you will get till 30, but those IP available IPs are very minimal. You will going to get over max to max of 10 IPs. So for 3 will be the reserved for maintenance and so things, and you will have a very few finite IPs. So no organization could own or could satisfy the requirement. So for that purpose, they have limited the subnets between 16 to 28. Fine, and let it be default. I don't want to have my dedicated things. Fine, we create it. So right now I have just created my network, my own network. So here I do not have any of the subnets, that is I do not have much IPs to create my resources. So all I have is my own network, that's all. Right? So look here. So here I just created my virtual network. So I do not have any resources to be provisioned or to provide IP. Haven't created anything here, and I haven't created the route table or the internet gateway. So we'll have it each and everything. Okay, so we'll have the internet gateway initially. Okay, so we'll provide IGW is nothing but your internet gateway, and we'll create it. Fine. So you have created the internet gateway to establish the communication between your private network and the public network. So you should attach your internet gateway to your private network. So right, to have communication to the outside world. So you have either two options. Either you can go with this pop-up one, or else you can go and hit attach inside that. Select your network. So now we have attached our network. So now I can able to access the resources whatever I going to deploy it inside. Okay, we'll go and create this subnet. So why should we require subnet? So to have any of your resources to be provisioned and having their own IPs, you should give this one. Fine. So here we'll be providing like one. So the availability zone will be 1 year. Okay, we'll change it to 1 year. Fine. So probably we have created our network, that is 192.168.0.0.60, and inside that network we can break. So we have around 65,000 IPs in our network. So we can categorize your network, or you can break that 65,000 IPs into multiple branches like that. So how will we go and see 192.160. Let's try it. See here. So among 65 IPs in this subnet, I will going to have 256 IPs. Fine. So how I got 256 IPs? Because of this CIDR block format. So if I go with 28, so see here. So only the 16 IPs are available. So likewise. So however you want, if you provide 25 like this, so we'll have a standard one, that is 256, and multiple subnets can be added to make your resources more available. Fine, we'll go and have in multiple zones. Here we'll be creating another. So these are my two things which are created under my VPC. Fine, we'll be creating the subnets to my network. So now what we done, initially we created our that is own network, and we established the connection to the outside the world, that is from private network to the public network, and to create our resources to have their own IPs, we created, that is, we shorten our larger network into two things, like that is subnet, and we are at with route tables. So why should we have route tables? So by default, the route table is created for this one. Fine. So we'll go here. So here we have route table. In subnet association, there is no subnet is associated to my route table. So any request is coming or going outside the things, so the subnets should be associated. Why? So whatever you are trying to make any request to outside the world, or if some request is coming to your resources, means each and every traffic is being taken care by the route table. So we should provide the path where our resources are exist. So for that purpose, we will be adding our subnets to the route table association. Fine. And also the route to be configured. So here, but by default, since we have created our public, private network, we have only limited access. That is, inside the AWS, you can access your resources. So if you want to access resources outside the AWS means we should give access to all. That is by providing the internet gateway, and we should select our network. So now it is being configured to access whatever the resources we going to create or we going to provision within our network can be accessed outside. Fine. So now we are done with configuring our own private network along with to provide or to create our resources. We created the subnets and to, that is, routes the packet inside your network and to transmit packet to outside and get the response to the intended one. We configured the route table and we associated the subnet, and we also linked internet gateway to speak to public network. So now we all done with this. You can have a look up your own network. So see here, so this is your network and which is associated with two sub networks, that is subnets, and where your subnets is associated to route table. From there they got connected to internet gateway. So this is so if you any request is coming, it will go here and then it will go out. If any request is coming from outside to your resources, it will come to, that is IGW, and it will come to route table here. Each and everything, that is your firewall is existing this layer. So your packets and your header will be checked and it will transfer the packets to intended. So based on the resources where it is available in the available source. Fine. So now we are done with creating the network part. Okay. Next we'll see what we have. Next is what is launch template. So we'll try to understand what it is exactly. So launch template in AWS is the resource that specify configuration settings for launching the Amazon EC2 instance. For example, assume that so instead of defining the settings every time you launch an instance, you created a reusable launch template with predefined values such as many of the configuration things. For example, so assume that in an organization 20 people are working. So all 20 people are in developer teams who requires same set of configuration of system. Fine. So instead of configuring or provisioning each time, so we can have our own image, that is the template of my configuration, like what kind of operating system and what is the RAM type and what is the size of the RAM, what is the size of the ROM, and in which network the resources should be defined, and we should provide security for it, like that. And we do have some predefined application, that is so all 20 employees are working in same project and they do require the same set of applications, like for developing, testing, to deploy all those things. So what they're going to do is they going to launch a new instance with all the required configuration and the software installed. They can create the template of it. So the same template can be used in future. So the same template can be shared across all 20 members and they can we can instruct them to go with this operating system or the system configuration. So only they need to have, just they're going to launch using this template ID or the name. They will have all the resources which are required for their development environment like that. So this is the advantages of having the launch template. So the launch template, once again we will come across it. So the launch template in AWS is the resource that specify the configuration settings for launching Amazon EC2 instance instead of defining the settings each time or the every time whenever we try to launch the instance. So we are creating the reusable launch instance or the template with the predefined value such as image. We going to specify the operating system and pre-installed software. So what are the softwares we want? We can add. So instance type. So define the hardware. So that is the number of CPU, RAM, cache, everything, and the key pair. So for SSH access, and we're going to have our own set of network rules and user data scripts. So if you have something to be defined, so whenever we go on with some configuration like that, and storage volumes, and also I have also attached permissions for AWS resources. So we can have restrict the resource access to our EC2 instance. Fine. So we'll understand. So why use of launch template? So it is more consistent. So ensure that all instance launched have the same configuration. Since we'll be using the template, so we will have the same configuration. So we won't miss out any of the resources of the configuration of the application. So reduce errors due to this configuration. Fine. Next is easy of use. So simplifies the process of launching instance as settings are predefined. So since everything is predefined, so we don't have to bother about all the resources and the softwares what should be used like that. So it is like ready to cook like things. So everything is ready. Only you need to launch that instance using the template. That's all. So we are only left with launching the instance or your server. So can include multiple versions. So as it progress further, so we might require to have some other application to be installed. So you can directly go into your template and you can upgrade your template, or you can go like you can have another version of your template too. Support for advanced feature. So used in auto scaling group. So this is why we will be moving from the scratch. So if I directly dive into the auto scaling and business load balancing, we won't be able to understand why we are using all these services or the features like that. So that was the main reason to pick the pre-understanding of these services. Fine. So probably in auto scaling. So what is, we'll go and try to understand auto scaling. As of now, we just understand these things. So support for advanced feature used in auto scaling group to scale EC2 instance dynamically based on demand. So anyhow, we do have our launch template, that is the packaged system which are already been defined. Just we need to launch it, right? So when it comes to auto scaling, so it will create the new server with the predefined template like that. So enable configuration like spot instance, capacity reservation, instance lifecycle management, everything. And also cost is optimized. So enables mixed instance policy combining spot and on-demand instance for auto scaling groups and optimizing the scale. So what, how the cost of optimization is achieved here means, assume that you have web application running in your one server, automatically the CPU utilization crosses the 70% or 100%. So gradually there might cause either your server may go down or it may crash. So to avoid those things, we have to launch our new server with the same application, right? So how we going to, again we need to configure all these things, like if we are choose to have manual process. So instead of having the manual process, we use launch template there. So based on the launch template and the traffic coming to our application will be monitored, and a new server will be launched with the base of launch template. Fine. So this is where the auto scaling or the cost optimization we have. So when there is no much traffic, so if your CPU utilization is less than 40%, automatically the whatever the server additionally got created during your the high traffic, those will be terminated automatically without any manual thing. So we will be paying only the amount for what instance is running for how many hours, like that. Fine. This is how you can optimize the cost. And we can have version controlling and flexible with modification override the specific settings from the template during the, so we can override the things if we want. So without altering also we can use it. So integration with all the AWS services work seamlessly with service like AWS Autoscale, EC2 and fault flows. Fine. So we'll go ahead and create the launch template. So to do, just log on to your instance and go inside your EC2, that is console, and from there you just got on to EC2. In left side we can have launch template and hit there. So if you already have your instance is running with everything like packaged application with your software and everything, so you can have it too, or else you can simply go here and you can launch it from here. Just name it. You can give the description, so for what purpose you are doing, and what are the configuration these templates ones, like that. So this is how either you can have your own, that is if you go for my AMIs, that is Amazon machine images, you can have it here. So if you already won your application, that is you have already deployed your application inside the Ubuntu instance with all the required dependencies, and you can create the IAM by own, and by launching the template you can choose it from here, or if you want to go with the new one you can just have it here. So here I will be going with Ubuntu server, which is the base provided by the AWS, right? So this will be the configuration you can have, and you can modify as you require. And the instance type, so here by default I will be going with the free tier, that is T3 micro will be having 1 GB of RAM and 2 virtual CPUs. And the key pair, if you do not have key pair you can have it by creating the one. And also you don't need to include any of the subnets. Why means, if your subnet one is filled already, automatically the resource will be created in the subnet 2. So if we have predefined our subnet 2 means, so it will always keep checking there, so whether to create or not, like that. So that is why we won't be choosing the any of the things here. Okay, so either we can go with our predefined things, or else we can create our new firewall. So we will have our own firewall things here. Fine. That is they call it as security group, and remember to choose your own network inside here. Okay. I'll try to go with this one. Okay, fine. So we'll create it now itself. No matter. So here we will be configuring the rule, that is custom IP to SSH, since we want to log into this one, and we'll add another security group, that is HTTP. Fine, and we'll go and provide IP public IP address to each instance which is going to create using this template. So whatever the instance is going to create should have the public IP address. For that purpose, I just enabled it, and you can manage how you want. And the storage. So by default, we will be having the 8 GB. So you can have by adding the add volumes, and also we'll be going with additional settings. And here I will be going with some commands to have my operating system, that is Ubuntu. Okay, so initially whenever your instance or the server got launched, it will check for the update. So if any updates are there, automatically it will update. So once after updating, I will be going to install the Apache 2 server in my instance. Okay, once the Apache 2 got installed, so I will create one index.html file which will hold the IP address of your instance. Fine. So here I'll be using the format like echo, that is head volume. Heading will be provided with server details, and the paragraph, that is the host name. I will be copying the name of my host and the IP from this one, and will be put it inside this index.html, and this is the directory path, and this is my file. Fine. So once after copying all these things, so we'll be restarting our Apache instance inside the, sorry, our Apache server or the application, and the output status, and you can, fine. We'll go ahead and hit okay. So we need to provide the description for the security group. Allow SSH and HTTP. So now the template got created, and this can be used for autoscaling things. So there also, next step, you can have this like launch this template from this template, and you can have it to autoscaling group and create the fault like this. We launch template. So this is my template. It's fine. So the versions will be here, like by default we have only one. If we have multiple things, we will be having the versions 1, 2, 3 like this. Fine. Now we are done with having the template, launch template. We understood. So why should we have launch template, how it is going to work and all. And we also created the launch template, right? Now we'll try to understand what is load balancer. So load balancer in AWS is managed service that automatically distribute incoming traffic. So incoming traffic is nothing but whatever the request is coming to your application will distribute accordingly, or application traffic across multiple targets. That is, we're going to have the target. Okay, such as an EC2 instance, containers, or the IP address. So it ensures the high availability. See here, it ensures the high availability and reliability of your application by balancing the workload across available resources. we're going to have our resources under the subnet, right? So on top of that, we'll be having the load balancer. So where it going to manages all the incoming traffics. So inside our subnet, we will be having our resources created. It could be your EC2 instance, RDS, Lambda function, Amplify, anything. Fine. Or your might be your Elastic Kubernetes like that. Okay. So by implementing the load balancer on top of your application, will handle or will take care of your application running smoothly. Okay. So it will going to distribute the traffic among the available or running service or the servers. So why it is required? If 100 requests are being processed by the each server cannot handle more than 100 requests. If 101 request is coming to the server, automatically the response time will be increased, or it may go down, or it may crash down like that. So the resource will be completely unavailable to the end users. To avoid all those things, so the auto scaling, right? So it will going to create another instances with different type. So if yeah, I will explain you people by showing the diagram. Okay. So as of now, we'll try to understand this. Fine. So we just understood what is load balance. So the main objective of the load balancer is to distribute all the incoming traffics to the network or it could be application. And AWS offers elastic load balancer, which supports several types of load balancer. So in elastic load balancer, we do have different kinds. One is application load balancer. So application load balancer operates at the application layer and route traffic based on HTTP requests, such as URL or the header. So based on the URL things, it will go to have network load balancer. So inside our that is we created the route table, right? There also we can have it. So operates the transport layers and handle high throughput and low latency. That is how data should be transferred. I know. And another one is gateway load balancer, that is IGT, designed for deploying and scaling virtual applications like firewall, instruction, deletion, sorry, intrusion detection system. That is, if some any anonymous trying to have access to our resources, it will be blocked like that. So next is classic load balancer, legacy option, supporting both layer 4 and layer 7, but it lacks advanced features of that is additional load balancer and network load balancer. Sorry, application load balancer as well as application load balancer. Fine. So what are the advantages of using the load balancer? Improves application availability. So since your incoming requests are distributed among the available instances of the servers, we can make our application available to all. So automatically reroutes traffic to healthy instance if one fails. So assume that you are running two servers and one automatically shows their health got down, server health, due to some reason. So automatically the new server will be created. So if you have created the new server, you need to again map your IP addresses. Definitely the new server will have its own IP different one. So again someone needs to take care of mapping the IP address of created server, right? So to overcome all those hurdles, we place load balancer on top of the instance, that is target groups. So whatever the server is going to create it and the target groups are directly linked to the load balancer. So load balancer will have single IP like that. So automatically it will make available even though if you have created with new things. Okay, next is distributed traffic effectively. So it will distribute traffic among the available servers so without stressing the single server and scales with demand. So it will be associated with the auto scaling group. So work seamlessly with auto scaling group to handle increases or decreases in traffic dynamically. If traffic got increases, automatically the load balancer will instruct the target group saying that there is a huge traffic coming, like that. So the target will group will going to instruct the auto scaling server. So the huge traffic is coming, kindly create another two server to handle all those requests like that. So automatically the auto scaling uses the launch template to create the new server. Fine. So again, the load balancer will instruct. So we are running normally, we do not have much traffic incoming. So we can optimize our servers running like that. So automatically it will instruct the target group, and target group will going to instruct the auto scaler. So the auto scaler that is built, sorry, the target group will take care of scale out the resources. That is only the minimal or the desired thing. Desired servers will run, the extra server will be drained out like that. Okay, scales with demand, that will enhanced security, AWS shields off. So also we do have multiple security things like denial of service protection, that is to hack any of the servers, they going to send lakhs of requests per second to confuse the things and to block the logs tools. Okay, we do have multiple security things like SSL, TLS, and L policies like firewalls and enables advanced routing. So it will route. So based on the path we provided or the host name. Fine. And simplifies the operation. So AWS manages scaling and patching and health check. So it will going to keep checking the health of the running instances and reduce operational overhead and support hybrid architecture. That is, load balancer can route traffic between AWS resources and on-premises servers, facilitating the hybrid cloud solution. Fine. So this is how the load balancer is all about, and we're going to understand the target group. So after understanding this, we'll go and create both the target group as well as load balance together. Fine. So what is target group? Is a key component of elastic load balancer. So your load balancer is going directly interact with the target group itself. That defines how load balancer route requests to register targets. So what they are telling is, so whatever the request is come to the load balancer, he is going to define how the load balancer routes request to registered target. So it will going to instruct the load balancer, send this request to this server like that. And targets within the target group can serve the same or similar type of traffic. Like that. So each load balancer must be associated with one or more target groups, which is used to distribute incoming traffic. So the load balancer should understand, right? So how many server is running under the same web application, where should be the traffic should be routed like that. For all those routing things, the target group will be taken care. Fine. That is simplified traffic management. So target groups let you organize and manage multiple resources. So target group let you organize, so we going to, that is target group will going to organize and manages multiple resources which are created at a rate. That is, it could be easy to instance or the container to handle specific type of request like that, and flexible routing. So each target group is associated with one or more listening or the rule on the load balancer to determine how requests are forwarded here. So you can route requests based on conditions such as path pattern or the image or the host or the event. So dynamic target registration. I just mentioned, right? So if you just created the new server under the same application, so the end user doesn't know the IP address of new server. So on that case, the target group will register itself by looking into any additional resource got created. So automatically It will fetch the IP address of that particular new resource or the in server, and it will be mapped to that load balancer. Like, so target can be automatically added or removed from the target group based on scaling action, ensuring smooth handling of on-demand changes. And health monitoring. So the target group will have its own health monitoring system. Unless until it seems to be healthy, it keeps creating the resources. So target group perform health checks to ensure that only healthy resources are received traffic. If the target fails, it will automatically taken out of the server until the recovers. Fine. And support for different workload. So target group can handle EC2 instance, IP address, and also for Lambda and Elastic container service tasks, providing flexibility for application architecture like that. And also it will provide more security like that. Fine. How it will work? We do have some scenarios here. So target registration. So add specific EC2 instance. So if automatically some EC2 instance got added or any of these, automatically the listener, the load balancer listener forwards incoming request to appropriate target groups based on the routing rules. So if any new resource got created under this target group means automatically they themselves going to have the registration saying that this is my IP, I will be available to supply that. So once it is got registered, so automatically the listener rule will be created. So thereon the traffic will be routed to that server too. And it keeps checking the health of the each and every service. Next is auto scaling. So we'll come back to this later and we'll have the practical session on creating the target group as well as load balancer. Same under EC2 instance, EC2 console. So you can navigate to the target groups by scrolling down. Under load balancer section, we'll have the target. You can just create, for instance, as of now we'll be creating, if you are creating for IP address or if you are creating for Lambda, you can go as if you want. Fine, the port 80 should be open, so this is how the protocol should go on, and you will going to have within our own network. Fine. So health check. So for health check, if we have path, you can have it here. Or else you can just. So if you already have created the instance, that will be pop up here, and you can integrate all those things. If there is no instance or the resources are running which could be associated with the target group, we can have it like that. As of now, we'll create the target group. So as it shows here, there is no, that is zero healthy, zero unhealthy. The load balances is not associated with that. So now we'll go and create the load balancer. Since we'll be using the Apache 2, that is the web application, we'll be going with application load balancer. Fine. We'll name our load balancer. Since we will be passing anything, we'll be exchanging data between the private network and the public network. For that purpose, we will be using the internet facing serves, internet facing traffic as the public IP address and the DNS will be having it. Fine. We're going to have our own network and we'll make available resources inside any of these subnet. Fine. And we'll do have a security rule because we'll be interacting like, so it says firewall we just created back while creating the launch standard. Fine. Here we need to associate our target group. So nothing much. We'll create the load balancer. So it's under provisioning. So it will going to create based on the instruction we provide. So we can have this DNS to access the resources which are provisioned under this one. So until it got created, we'll move on with next topic, that is auto scaling. So what is auto scaling? So auto scaling in AWS is a feature that automatically adjusts the number of compute resource. Fine. So compute resource, that is what they are trying to tell is, so we can automatically or dynamically create the servers as it requires without any manual process, such as EC2 instead, to match the demand for your application. So if there is a huge traffic coming, so only you have one server running here there. So additionally, you require two additional servers to process the on-demand request. On that case, by using the template or the launch template, the auto scaling will going to create the same set of resources to process the on-demand request like that. Okay, it ensures your application has the right amount of capacity to handle the traffic effectively, sorry, efficiently, while optimizing the cost by scaling down resources when demand decreases. So when normal flows goes like 10 requests are coming an hour, on that time you don't require to have multiple servers to process those 10 requests. You can have one is more than enough to handle it, right? So on that case, automatically the rest to which got initially automatically created during the high demand, that will goes down. So on that case we can optimize the cost. Fine. So auto scaling to groups, a logical grouping of EC2 instance with policies to define scaling behavior and manage instance launch and termination to maintain the defined number of healthy instances. We'll try to understand by looking at in practical things so we can able to get it more clearly. And scaling plan everything. So why should we go with this one? That is improved availability. So automatically replace unhealthy instance and scales up the resources during the spike, traffic spike. Fine. So what they are trying to say, it is if the target group finds the server is unhealthy, automatically it will create the new server and it will make it available to the end user. And cost optimization, as request as traffic spikes high, automatically the instance will be created. If traffic goes down, automatically they drain out the things. So dynamic scaling, as I just mentioned, right? So adjust the resource based on the real-time metrics like CPU usage, network traffic. We can customize the policies as we require. And predictive scaling. So use historical data and the machine learning to anticipate on-demand changes. Like we can use previous data to do these things. And operational resilience automatically handles instance failure by launching new one, minimizing the downtime of the resources. And also the workload adaptability. So supports the wide range of use case from high traffic web application to batch processing job with fluctuating compute needs. We'll look into our resource whether it is active or not. Okay. So what we did from starting, that is we created our own private network and we established communication to the public one. Thereafter, we created the launch template, that is our packaged operating system, along with our application, right? Once after that, we created the target group. So why we created the target group? To instruct or to make our resource available to the end users without any issues, and to for more reliability and scalability things, we created the target group. So to handle all the requests and to divert between the resources, we created the load balancer here. And if there is high traffic spikes. So what needs to be created? That is additional server to be created. So what additional server to be created with our same existing server? Like for that we need to have auto scaling here. Okay, so we'll create auto scaling, we'll name it. So here we will be creating the launch template. So launch template. So choose the launch template that contains the instance level settings. That is, so whatever the settings you wanted to create on demand, what they are telling, like IAM instance, key pair, security groups, and all. So that will be here. So if you have multiple options, we can go with this one. So by default, we have only one, and we'll be hitting the next. Now we come instance type requirement, everything pulled out from existing, and the network settings. So here we need to provide, and we'll make it, we'll give access. So wherever it is available, let's go and create the things. And balanced and best effort will be recommended. Fine. For available. So subject to available of IPs, it will going to create the instance. And so we need to handle we need to have our security, that is load balancer. So without load balancer, we won't be able to manage our requesters and as well as our server, right? So here we'll be attaching the load balancer. So if you don't want to attach your load balancer, even on that case also you can go on, or if you want to create the new load balancer, we can create it here itself. It's not required to create existing like that. So choose from your load balancer target group. So we already created the load balancer, that's why I just gone with this one. We'll keep everything as it is. And health check, here we will be turning a health check. Fine. So turn on elastic load balancing health check. So it will check for the network or the traffic, how much it is coming and all, and the elastic block storage also it will going to check. Based on that, it will going to provision. So how often it should check? So for every 15 seconds as of now we'll provide it. Fine. So to show you people, so every 15 second it should check for the health of the servers. And if they found unhealthy, means automatically the new server should be created like that. Fine. And here desired capacity, choose the unit of measurement for the desired capacity value, are only supported for mixed instance group configuration. Fine. So desired, so I want minimum to be 2. And scaling limit, so set limit how much your desired capacity can be increased or decreased. So minimum desired capacity, so minimum it should like create 1, so maximum you can have 3, or you can have 1, or greater than or equal to desired capacity. So it should be equal to your desired capacity or should be maximum like this. We'll have it to 1. And automatic scaling, so no scaling policies. So if we go with scaling things, we can have it. So target tracking policy, the name of the policy, and metric, so average CPU utilization. So if your CPU utilizes 50% of your CPU, automatically it will grow into create the new instance like that. Disable scaling is to create. We can also have this one, so disable scale into create only a scale out policy. We can have the scale out policy like that, all those things. So we don't want any as of now. And instance maintenance policy, so we can have this as we required. So for rebalancing event, new instance can be created, launch instance before terminating. So it not to, if it is found unhealthy, means automatically the new instance should be created without waiting for termination. So mixed behavior means combination of all these three. Fine. So we'll go and we can add notification too. So if any additional servers got created, automatically the pop-up will be prompted. So for that we can have like SNS topic, that's a launch, add notification, and tag. So in SNS we can have. So probably just I forgot to show you people. Now see here we do not have any instances. So there we mentioned two as the desired one, right? I will hit refresh. So automatically the two got initializing it. Fine. We'll try to check the health of these two instances. Now, now the instance is initializing. That is, the automatically the instance whichever it got created by themselves, they got registered to this one. Okay. So till there we can copy our DNS to access the resources we have deployed in our. So we need to wait till our resource got launched. Fine. So one is already been working probably. See here. So one is healthy, one is unhealthy. Why it got unhealthy? We'll have it here. So there might be some internal issue it could have created to lead to unhealthy thing too. So probably okay. So now it has detected with unhealthy, right? So automatically it will wait for 15 seconds from the state got unhealthy. So if it is not, it will going to create another resources. See here 192.168.2.110. So do we have that IP 192.168.2.10? So this server is I am right now I am accessing this server. Well, see here. So automatically I did not do anything. So automatically the unhealthy report got detected and automatically the new instance got deployed. So fine. So we'll try to refresh whether we can. As of now, only one healthy got detected. See here, automatically it is draining. It will going to terminate gradually. We'll try to refresh and whether it will going to redirect to another thing. We'll have a look on it. The things got fast, but still it has not yet updated here. So it is not at all your fault. So it's completely default in the AWS itself. So don't worry if this error if you encounter. So your instance are healthy, but still the target is showing unhealthy. Fine. So since we provided 15 seconds, so within 15 seconds it should be run like that. So if we have provided the more one, we can add that edit. Okay. We'll have it for 20 seconds and we'll update the things. Fine. So now we got into See here, without waiting for 20 seconds, it started creating new things. Fine. Let us see that. We'll try to terminate all these four instances, and will it going to create another two instances or not? We'll try to see. Fine. See here, 4 is out terminating, right? See. So the request got timed out since the server where we were able to access the resource already got terminated. See, automatically the instance is creating here, showing us pending, right? Okay. And we'll try to access this whether we can able to. Still it's under initialization. See, 192.168.1.52. So what is the IP? 192.168.1.52. So this is how the auto scaling is work, and the load balancer and target group by all these associations, it keeps working like this. Now still it's showing unhealthy, but we can able to access, right? We need to maximize the policies. Okay. So always ensure that you're going to delete the resources after your practical things. Fine. When I will be showing that too. So you delete these things and delete the load balancer initially before deleting the target, since load balancer will be associated with the target. So now we go and delete the target group. Fine, and what we else created is launch template. If you keep it as it is, don't get any charges, but still you can delete since we don't require anymore. Fine. We'll refresh our whole thing. Meanwhile, probably, so once we deleted all the resources, automatically the server by itself is shutting down, since it was created from the configuration we did existing, right? For that purpose. Okay, so now whatever the resource we created under ECT console, we have deleted everything. We'll just try to log into our VPC and we'll delete there also. just select under your VPC and delete. So automatically it will going to delete which are associated. It will show you here like IGW, subnets, and the route table things. Fine. You can have your own custom route table too, or whenever you created IGW, automatically the route table will be created by associating to that network. So this is the default one. So if you have deleted by any chance default which you can just create under action, that is create default VPC like that. Okay. So this is the thing all about auto scaling and load balancing, everything. Fine. So this is the pictorial representation what we have just created. So initially we log into our AWS account, that is Amazon Web, and we switch to Stockholm region. Under that we created the VPC, our private network. Under private network we have created the load balancer to manage the traffic which are coming from outside, and it will going to distribute to the target, like it will be transmitted to target, and from there it will transfer, or it will send request to appropriate instance under submit, like that it is fine. So always, for more best practice, make available of multiple zones. Okay, as it should be at least two. You can have as many, that is will commonly have three things, at least maintain two things to make your resource more available to the end users. Thank you.